3, 2. Hey guys, so the first question is search inside position. So given a sorted array of distinct integers and a target value. So we have to return the index if the target is found, if not return the index where it would be, if it were inserted in any order, and the algorithm should be returning O of log n time. So the question is given like that. So the answer or the values lies in between minus 10 raised to 4 and 10 raised to 4. Nums contain distinct values that is sorted in ascending order. So the numbers are already sorted. So I think from here itself we almost got an idea. Then it should be length should be in between 1 and 10 raised to 4. So here the numbers are given 1, 3, 5 and 6 and the target is 5. So we have to search for that number and have to return that index. So here 5 is there, it is at the index 0, 1 and 2. It is at the index 2, so we are returning 2. But in this case 1, 3, 5 and 6 we have to find the target 2. So as 2 is not here, we have to return that index where it can be. For example, so here it is given as 1, 3, 5, 6. So 2 actually should come here. So this is the position of 2. So what we have to return is we have to return that index where it can be 0 and 1. So we have to return the index 1 here. So that's what we are doing here. Similarly for here target is 7. It is 1, 3, 5, 6. So 7 is greater than 6. The element is not inside the array, so we are returning 0, 1, 2, 3. And it should come in the fourth position. So that's what we are returning is. So there is no special case considering this. If it is coming in the first position, also you have consider the target as 0. So we have to return the index as 0 because it will be on the very first position considering this array, and array is already sorted. So first approach that comes to our mind is brute force approach. We can directly run through the array, read through the array, and we can search for the element. And if it is not there, we are just returning the previous position. So but the brute force approach will take off in time and we have to make it more optimized. So the better solution for this is we can use binary search. So binary search, as we all know, it works on sorted arrays. The array is already sorted, which is given there. So we can search using the binary search approach. So I hope you got the idea. So low and high. So low will be the 0th position. High will be the last position. So let's see why low less than equal to high. The condition for that array, I'm initializing the mid value that will be low plus high by 2. So first I'm going to check the condition for returning the answer. So if the mid value, if that mid value that at first the array will be splitted, I hope you know binary search well. So if the middle value is the target that we want to search, we are returning the mid position. Now what we are going to do is if the mid value is greater than the target, that means target comes in the first half of the array. Suppose this is the middle value at first and this is the first half of the array. So if the middle value is greater than the target that we are going to find, in this case you can see if I'm taking this as the middle value at the first step, it will be split into half. So 5 is actually greater than 2, it comes in the first half. So that's what we are doing here. So high is equal to mid minus 1 is low is equal to mid plus 1. So that's the condition for finding the array, if finding the target if it is inside that array. Or else what I'm going to do is the target is 2 now. So in the first iteration, suppose this is the middle value, 3 is greater than 2, we goes into the first half of the array where there is only one element. So this will be the middle value. So there is nothing, the element is not found, so we are returning that index. That means 0 plus 1, that first index. So we are just returning that low. Yes, this will work. Let's see. Oh, sorry, none is off. Okay, that's all. Let's see again in another video. Thank you.